Now we have two more laws that Dalton was dealing with and that he worked out. And one law is the law of definite proportion, and one is multiple proportion. And it's kind of weird because we're using a lot of words that are the same in the two different laws. So in the definite proportion, this is just a little mnemonic. I mean, it's not really, it's just to help a little bit. So it's when you are definitely sure that the substance is pure. That's when you're talking about definite proportions. So you're talking about one type of thing. Multiple is when you're dealing with multiple substances. So what they used to do is they used to take something that they were sure was pure, and they would cut it into different amounts, and then they would figure out how many how much sodium mass was in there and how much chlorine mass was in there. And they'd figure out the ratio of them. So what it says is within the same compound, the mass ratio of the elements are the same. And these pictures are not perfect because it's not showing, it looks like the atoms are cut off, and they should not be. So imagine that all of those, that it was cut in such a way that all of the atoms are actually full atoms. So that's one thing it's hard to do with these pictures. So all the atoms and all the edges here are the same. But what they do is they take a big nice size sample, and they would separate the sodium from the chloride. And then, for example, they'd find out that they had a certain mass of the sodium and a certain mass of the ratio of the chlorine, and that ratio always stayed the same. Maybe it was a 1-to-1 ratio. Of course, the sodium chloride it would be. But they did it for a lot of different things. Then what they do is they would break off a little section of it, and then they would figure out that ratio. And again, they kept coming out that it was the same ratio. And then they would break off a larger section. And then again, they would come out with that same ratio. And so what they figured out was, well, when you've got something pure, doesn't matter if you've got a lot of it or a little of it, you still have the same ratio of elements. So that kind of gives us some answers about atoms if we think about it. So what we're kind of going to be leaning into, what they were realizing was that one atom of sodium was being paired with per one atom of chlorine. But they weren't there yet. They were just comparing the ratios. So at the same time, then they would do these comparisons when they knew they had similar things, but that they weren't the same. And so some elements can combine with different amounts of other elements. But when they combine, they still combine in specific mass ratios. So if you have the multiple substances. So everyone's heard of carbon monoxide. It's really dangerous. You don't want to breathe it in. And you've also heard of carbon dioxide, which is obviously something that's throughout our whole bodies, and we're constantly breathing it in and out. So we know that those are two very different things. They are not the same thing, but they both are made of just carbons and oxygens. So they wouldn't have done this with a gas. They would have done it with some kind of a substance. But this is a gas that we know both of those fairly well. And again, they would break it down, they would take the sample and they would break it out, and they would say, well, everything that's carbon monoxide always has a 1-to-1 ratio, and everything that's carbon dioxide always has a 1-to-2 ratio. And they would say, well, even though they have carbon and oxygen, they are not the same. And they would say that, well, even though that's the case, it's interesting because they're still combining in these specific ratios, 1-to-1, 1-to-2, 1-to-5. So that was what they also were talking about at that time. And again, an implication of the law of conservation of mass is that mass is neither created nor destroyed in a reaction. So the laws that you need to be aware of are definite proportion, multiple proportion, conservation of mass, and conservation of matter.